Hi, welcome to Donegal Dad. I'm Mark. Today we're going to be looking at points, the different types, how they're used on DC and DCC layouts. So here we have some examples of the different types of points you can get. We have curved points, we have larger radius points, sometimes called express points, and then a smaller radius point. We even have a three-way point. Now if you look closely at these points here, this is an electrofrog point, and this is an Insulated point. You can tell that by looking at this area here, which is called the frog. You can see this is all metal, and on this one here it's plastic. We'll discuss more about these later on. So this is just a typical point. You have the tie bar here, which is connected to the blades of the point, which move the points and divert the train down either track. This area here, as I said before, is called the frog, and these rails here are the check rails to keep the wheels in line on the track when it's travelling through the point. So let's look how points work on a layout. So points, they will come in a left and right. You can see on here I've drawn in a left point. So the train's going around the circuit. I've coloured this with my usual wiring colours, so black to the back, red on the inside, and I've done the same with the siding. So if you have the point there and you have the blade set straight, the train will go around and carry on going around in the circuit. If you flick the blades over, now when the train comes along, it will go up the siding. Now one of the most common questions I get asked is about wiring with points. If you put your power supply in, and we're talking about DC at the moment, so if you connect your power supply here, the power goes all around the circuit, but when you flick the blades to divert it, then you cut the power off here. Now that's fine as long as you've got a good circuit, but say if you have a dirty fish plate or a break somewhere around here, then the power is only going to go in this section here. It's not going to go all the way around. So when you're putting your power supply in the DC current, if you're putting it in one place, then you always put it before the point work, so somewhere over here. Now if you're using a bus wire and droppers, you don't have that problem because you're putting connections in all the way around to give you a good secure circuit. So that's DC. So with a DC system, you can use the blades to control where the power goes. So with it flicked down, the train will go up into that siding, and then if you flick it again, it cuts the power to that siding and the train will stop. Now if you want power to this siding all the time, this rail here will always have power going to it, but this rail here is controlled by the switch blades. So you can simply connect the power, put a lead in going from here to connect the power, but then that means that this is always live. So in a DC system you can't just have a train sitting here because it'll always be live and always want to move. Now if you're using a DCC system, that makes it a lot simpler, because with a DCC system every bit of track is going to be live, because with that system the power is always going to the train and it's the chip in the train that tells it what to do, whether it's to move forward, switch on lights, generate the sound. So you can have all parts of your track live. So you could put a feed in here, over here, and over here, and as long as it's the right priority set up, then no engine will move unless commanded to by the control system. So with a DC system, you most likely would have a buzz wire running around with droppers connecting all the different bits of track, so it would be constantly live. Now to control the points, you can either control them manually, just flicking them across by hand. I use electrical solenoid motors. I've got a couple of different types here. These two here are SEEP point motors. One is a PM1 and the other is a PM4. The PM4 you can use with switches that you've removed the spring on. So it's inside here, they have a little spring. And see on this one it's been removed, whereas this one's still got it. So this one is a latching point motor to latch and lock the points in place. Pico do a similar little solenoid motor. These are a bit more cumbersome because you've got a bracket there to fit that to fit it to the underside of the board. And then you also have this little micro switch which you can use on there to control things like lights to go with it, but normally they're used to control the electrofrog point, which we'll come on to again later. These solenoids, they can be bolted or screwed directly to the baseboard, and they also have the wiring straight on there for the switch. So they're a lot simpler and easier to use. So to operate the point motors, you would have them wired into a switch. This is called a passing contact switch, where you just flick it up and down to change the point. It returns to the center and sends a charge to either side of the solenoid to move it across to flick the point. These are powered by a CDU, which is basically just a bunch of capacitors which gives the solenoid a good bit of power just to get it to flick over. So let's look at the difference between an Insulated and an electrofrog. So the electrofrog is all metal, as opposed to the Insulated where it's all plastic. Now the advantage of having an electrofrog is that it continues electric conductivity here. So you have something like an 040 loco, which is only a couple of pickups. It won't stall on the point, whereas it can stall on here. If the connection hits this plastic part, it can stop because it's not picking up any electricity. But it also means that the wiring of this can be a little bit more complicated. Now you can just put it in like that and allow the blades to control the power that goes to the electrofrog. You must put insulation fish plates on these 2 points here, or it will cause shorts. But using a point motor like the SEEP motor I showed you before, you can wire it up so it controls the electricity going to the frog. Now if we turn it over, you will see there's a wire hanging down here which is connected to the frog, and quite simply on the SEEP switch you have point F, which I code with a green wire that to the frog, and points D and E would go off to your positive and negative side of your bus wire. And then these other wires, the red and the yellow, are to control the solenoid, and the black is the common for the solenoid. So if we're using a point motor with a switch on it to control the frog, there's a bit of work we need to do to the point itself. So we'll look at that now. So normally the blades would control the power going to the frog to control it. But if we're using the switch, then what we need to do is on the back, you will see this join here with a wire going across it. If I flick it over, you can actually see there's a gap in the rails there. So we need to snip those wires there, take them off completely. You can also see the wire is here for the electrofrog. You can pull that out. You have to be very careful with this because it can be quite delicate. It doesn't always want to come out. So there it is there. Okay, and what we can solder onto that is a bit of green wire to connect onto the green wire of the switch. At the same time, to give a better electrical connection, I will solder on some droppers across here. So from here down where the cut is, this will be kept live by the bus, and this section here will be kept live by the switch on the SEEP point motor. I've also stuck the insulation fish plates on the end there. These are just little plastic fish plates. So I'll do all those modifications now and then I'll come back. Here's the point prepared. Green wire onto the frog with a bit of heat shrink over it to protect it. These wires have been snipped and removed, and then dropper wires have been added to go across these two rails here. Now make sure when you're fitting these that it's the right way around for the orientation of your point on your layout. So this goes with mine black to the back. So to install your point in your layout, when you're happy with the position of where it's to go, I use a little pin vise with a small drill bit in it. And you have the blades centered so they're not touching either side but in the center. And make sure the bit you use is smaller than the hole, because you don't want to make that hole any bigger or it'll give play. And just drill a little hole to mark it, and also mark where the droppers are going down and mark where the frog is to go down. And when you take it away, you've got a mark left behind. You can drill a 12mm hole for the point motor and then a 3mm hole for running the cables down through. So here we have the points installed. You can see the point motor bars coming up through the tie bar there. Now these are quite long because they're designed for different thickness of baseboards, so you will have to trim it in length once you've completed the fitting. So now we'll have a quick look at the wiring underneath. Now this is where it's important to have your color codes so you know exactly what's going on. Now this wiring needs tidying up, but you can see the green wire is going off to the frog. The red and black are going off to the bus wire to be connected in, and the yellow and black and the red for the solenoid switch have yet to be wired into switches. To fit the point motor, I put some wires in either side of the blades to keep it in a central position and fit the point to the track. Likewise on the solenoid, I use a piece of foam to keep it centered. And then simply when it's on, you come up through the baseboard through the hole you've already pre-drilled and slot it. It's going to be the tricky bit. Slot it through the hole. Now you want to make sure the motor is parallel with the tie bar. You don't want it like that because the solenoid won't throw it. So it needs to be like that, parallel with the tie bar. And simply screw it into place and then test it. And if it needs any adjustment, undo the screws and readjust. Now if you're using a DCC system, you can use that system to control your points as well. You simply get decoders, wire them into the points to control it through that system. I prefer using the analog method with the switches, because what I do with mines is I connect them using diodes, which give me routes, but that'll be a separate video on how I do that. You can set routes and everything using your DCC system, but I prefer just having the old-fashioned switch just to click. Let's talk about some of the issues you can have with points. Now ideally you would have electrofrog points with a seat motor with a built-in switch, and you'd be powering the frog and have droppers on your point. That will negate a lot of electrical issues you would have. But if you haven't got that and you're relying on the point blades, you can get bits of dirt inside here. If you've got it ballast can get stuck in there and cause a problem if you're relying on these blades to carry the electricity. So keeping them clean is important. Some of the other issues you can have is wagons derailing on the points. Now this could be down to what we call the back-to-back. This is where you'd use a little brass tool like this, and you simply slot it between the wheels just to make sure there's the right gap. And that will mean it will go through the check rails fine. The other issue you can have, if you look at this Hornby point here and compare it, the frog areas, you will see that the area around the frog on the Hornby point isn't as deep as on the Pico point. Now if you've got some older stock with bigger flanges, it can ride up over these points and derail. So there's a couple of the issues you can have with points. Hope you found that useful, a little insight into points, how to wire them and some of the issues with them. So please leave any comments down below, and don't forget to like, subscribe and share. And thanks for watching. I'll see you next time. Bye for now.